guys, welcome back. So in this video we'll talk about certain relationships which we must know in order to proceed. Like these are relationships which might come in the numericals. So we'll just see what all are the maximum number of relationships we can have and the most important quantities. So for that I'll just write down the equations that we must know that we have done in the previous two videos. So the first one we must know is that resistivity equals R A by L. This is from the grade 10's formula that R is equal to rho L by A. So from this you cross multiply to get rho is equal to RA by L. So this is the first formula we require. Then we need to know that conductivity is just the reciprocal of resistivity. Conductivity is represented by sigma is 1 by resistivity. So if you substitute resistivity over here, you'll get L divided by RA. So this is conductivity now. So after this, the formula we need to require is for drift velocity. We did that in the previous video and it was equal to E tau divided by M. There was another equation for current in terms of drift velocity. I is equal to electron density times the area times the drift velocity into the charge of one electron. There are four terms N, A, V, D, E. Then we need to know that electric field, the potential is equal to electric field times the distance. This might come in handy sometimes. So with these we can now derive resistivity and conductivity. So first we need to, before we go ahead with that, we need one more, that is current density J. J is equal to I divided by A. So all we need to do now is find resistivity and then we can take its reciprocal to find out conductivity. So now let's see how to proceed with the resistivity derivation. So we'll write down what we know already, which is R times A divided by L. Now we need to somehow introduce any one of these four, let's say, any one of these into this term. But we do not have anything similar for now. So we're going to convert resistance of this conductor in terms of its voltage and current using Ohm's law. So R becomes V divided by I from Ohm's law into A by L. Now we are going to change voltage, which is potential difference, in terms of electric field using the relation V is equal to ED, but in this case it's going to be E times L. So I'm going to change V to EL by I times A divided by L. L and L get cancelled and you have E A by I. Now I'm going to substitute for I. We have I. E A divided by N A V D E. Can cancel off the A's and we are left with E divided by N V D E. We can stop here, but if the question has given you the velocity of electrons directly, you can substitute, but if they haven't, we need to substitute for VD as well. And when you substitute for VD over here, the electric field gets cancelled off and you have the final answer as M divided by N E squared tau. This is the resistivity in terms of the drift velocity of the electrons. Now if you take the reciprocal, you get the conductivity. So conductivity is just N E squared tau divided by M. So this and all these are the relationships we need to know to proceed with the numericals. So after this we'll be looking about mobility. So now let's go to the mobility. Okay, so mobility is denoted by this Greek alphabet mu, and what it says is how much free an electron is to move. Magnitude wise it is represented by the magnitude of drift velocity. The velocity could be negative or positive, but we just need the speed, we can say. We do not need which direction, we just need how fast it can move per unit electric field. So mobility is defined as the drift velocity of electrons per unit electric field. So this is mobility. The only place this is used in our syllabus is for numericals. You just need to know the drift velocity and the electric field to calculate the mobility of the electrons. So this is it for today's video, and in the next video we'll be looking about the limitations of Ohm's law, how the Ohm's law fail at different situations. We'll look on Ohm's law, and then we'll go ahead with the temperature dependence of resistivity. Okay, so thank you for watching, and I'll see you all in the next video.